Hello, I'm Jean-Pierre Evain from the European Broadcasting Union, and I'm going to tell you a few words about Fims and the work that's going to be done on the semantic representation of its data model. So Fims is a joint project from the AMWA and the European Broadcasting Union, and we have been running the project for 5 years, and I'll tell you briefly what Fims is before we get into the core of the subject. The guiding principles of Fims are that we want to go from a situation where you have systems which are monolithic without any interface into something that is more modular and where we have these different interfaces defined for the different types of processes that you commonly find into workflows. And we have already done several of these services, and I'll come back to that. And what is a service? An interface that is like an API, a connection between two systems, and what we are doing is providing some information on what is the content, what it should be done to that content, and the service deals and does what it has to do with the content, and then it returns information on where the content is. And because we know what media is and there are big files, so we also provide all sorts of information and notification about the status of the system while working. What do we have with Fims 1.2? We already have an interface for capture, for transfer, for transform. We have the repository. We have quality assessment or quality control. We are working on automatic metadata extraction. We are working on growing content. We are working on the semantic representation of the data model. And we have already done some solutions to better deal with partial content and time code. So let's get to the core of the presentation of today, which is about semantic data modeling. That's what it is. Semantic is actually very simple, if you look about it. If you read the different specifications from the W3C, you might find this a little bit hard to swallow, but eventually it's not so complicated. So here on this picture, you see a very simple representation of a Fims graph around a program and a part of a program, and what you can note is that this can be described using very simple sentences that are called triples. Okay? So what are these triples? As I said, very simple statements. You have a subject, a predicate, and an object. Okay? In some cases, you would consider the subject as being the domain, and you would consider the object as being the range of the property. And the postulate of semantic web is that anything, how complex it can be described easily using triples. So you can start making, for instance, describing a car, saying, this is a car, the car is blue, the car has an engine, and you go on and on and on, and you can describe the entire car using that sort of very simple statement. And because anything can be represented using that sort of simple statements, then you could think that at the end of the day, triples might become the new common format for metadata. Because you could transform any metadata from any production silo, for instance, into triples. And then relations between triples are going to be made, again, using triples. So this property is equivalent to that property, that class is equivalent to that property. This instance is same as another instance. These are the things which are defined in the different vocabularies. So the predicate, that's exactly these properties. That can be two sorts of properties in the semantic. Either you define relations between classes, objects, or you actually specify some characteristics of a particular object. So one is object property for the relation between resources, and the data property is going to point to a value. So literal is used here, but literal covers everything from Boolean, string, whatever. And at the end of the day, the use of an ontology is first to have a reference, because you can very well populate a triple store with a lot of properties and classes that you have defined on the fly, okay? But it's better to have an ontology as a reference, or later, if you want to do some inferencing, then you are going to need this ontology to allow you to discover knowledge, to build knowledge from the data you have. And a resource, everything is a resource in semantic. So that's one of the of the key things that you need to realize. Everything is a resource that needs to be very well identified. So there are different possible identification strategies that could allow you to create identifiers on the fly without having to refer to lookup tables or whatever. So sometimes this can be very useful. And in fact, you can have relations between resources, and that is very important. So it's a resources type, and your ontology is going to have a number of resources with particular types. So for instance, a program is going to be a type of resource, a part is going to be a type of a resource, of another resource, etc. With semantic technologies, it's extremely easy to do extension and customization. As I said, you could even write an entire set of data without referring to an ontology. So that shows to which extent you can really create something completely out from your mind. You could decide to create a new property, you could decide to create a new class. But if you want to do things properly, if you want to follow best practices, then you better do an ontology. But if you come with an ontology, and if you want to speak or share or exchange data with somebody who has got a different ontology, you have different options. You can import the data from this other domain into your domain, okay? And then you can create relations between your resources and the resources coming from the other domain. Or you just leave them there. That's not breaking your model. Okay? You may just use these properties in addition to what you have without having the need to create any particular relationship between what's coming from the other domain and your domain. So really, whatever you do, you are never breaking your model. Even if you make an error in a namespace or whatever, yeah, then an error in a namespace would, in particular, be the fact that you have forgotten to declare a prefix. Okay, so if you come with data where a prefix is not declared, the model is not broken. It's just going to appear as a full URL. So it's extremely robust. So it's easy to use, and this principle of triples is really so basically fundamental that it's really easy to understand. Then reasoning is the step further. It is the fact that you can create knowledge, you can derive knowledge from what you have as a data. So for instance, if you have, the easy example is this: if A equals B, B equals C, then A equals C. Okay? So it doesn't have to be expressed as A equals C. It's going to be derived from your data. So semantic methodologies allow you to do that and extract this information from the data you have. Of course, this can be much more complex than this. It can be used to simplify your data set, because then you can look at inverse properties as one way to discover content, etc. So this is extremely powerful. And as I said at the beginning, so you have all these different metadata production silos. Most of them have different metadata formats. So if we can bring all these different metadata, sets of metadata into triples, then we put all these triples into one triple store, we build relations as see fit, and then suddenly you have all your metadata at hand. So that's very, very easy. So that takes into account the fact that probably there will be also new metadata workflows, new way of dealing with triple stores, databases, so things to be think about, to be developed. But for instance, you can have already a farm of databases of triple stores. You don't have to have all your information in one and single location, but you can associate these triple stores together, even if they are remotely located, so that they look like a single triple store. So these techniques exist. So there is a lot to be done around this. Yes, what happens next is that we have been looking at Fims 1.2, and Fims 1.2 already has a solid data model, and the different parts of the data model are everything that has to do with the profiles, then the jobs, and then the content, all right? And for the time being, what we have done is focusing on this part of the diagram with the BM object, the BM content. We have changed the name of BM content format into BM essence. because it's more logical from a class naming perspective. And then we have the different sets of metadata allocated with it. That has taken us this far, all right? So what do we have? The BM object. So the BM object is something that is only used as a job level, okay, for grouping content. Okay. Then we have a number, it's associated with a number of BM content, okay, objects. Well, this is where the difficulty is, that we speak about resources and objects. So I am tempted to say BM content object, but I should say only BM content. Right? And the BM content is associated to BM essence, which was called before BM content format. Okay? But from an ontology perspective, it's a better name for BM content format, because the format is not really a class. So BM object, BM content, BM essence for BM content format. And then we find exactly what we have today in the model. We have the format, we have the video format, we could have the audio format, data format, container format, and we have the locator, BM essence locator. So until now, the only one thing that we have changed is changing the name of BM content format into BM essence. That's all what we have done. All right. Now what we have added is that because you are in this semantic environment, you can create a lot of relations with other resources, which can be anything. So we have already introduced the QA report. There's going to be AME report, so that could be sets of metadata, could be PDFs, could be images, could be anything. So we can establish links to resources from the BM content and the BM essence. And then we have this other part with the timelines and the segment. And here we are discussing now because we are not quite sure about what could be missing here, and whether, for instance, a segment could be seen as a BM content or not. That's the discussions we had in Fims a few months ago about deciding whether a piece of an apple should be like an apple. But I won't go further with this. So that's where we are. We have made some progress. We have already written one first RDF representation of this. We want to do it piecemeal, because otherwise if you write all the properties, including the data properties, into it, then that can be very heavy and difficult to analyze. So for the time being, we are working on the identification of the classes and the main relations between the classes. And once we are happy with this, then we'll start importing all the data properties to characterize the different objects. So this is all the different members in Fims, probably incomplete. There are probably more, but no space on my slide for all the different logos. I should work on it. And these are different links for contacting us. So an important one is fims.tv. You can email me at evain@ebu.ch, evain@ebu.ch. And then more information on the YouTube channel where this video is going to be found with many others. Thank you very much, and well, see you next time.